Okay, I'll make it shorter. We're going into time. Or talk about sex. We want to check time. Time in many respects is much easier than playing with geography, although the same golden rule that Tom explained, play is what plays. You have to play with it. And you have to play it making reasonable assumptions to see what's right and what's wrong. One big advantage of time tags is that they have a much more limited spectrum of errors. The possibilities of getting a date wrong are much less. At least now that we are all into this same type of Gregorian time. Julian times are no longer in use, although you might find dates which are 18 days away in all ledgers. That might happen. Well, so we're basically into the second dimension of into the third dimension of what PBR is, what, where, and when. I'm going back to our whales. This is the recording of whales that we saw in the morning, where they were caught. Luckily enough, there's almost no one inland except for this one, which might have been this whale that came out in the Hitchhiker's Guide from the Galaxy, but I'm sure. But basically all of them are where they should be. I'm talking about, remember, humpback whale. Okay? So, all of the records that are available do have a name, whether this name was homogeneous or not. We saw in the morning that there were several different names. And 97% of the records have been georeferenced, which means that 3% of the records are not here. You cannot see them because they don't have a reference, a coordinate. But only 91% of the records do have a date. So when were those whales seen? For 9% of the records, which is quite a bunch of records, we have no idea whether they are recent records, old records, seen given at the proper time or outside their time. So the first thing that might happen with data records is that they might lack dates. And even if they do have dates, those dates might not be correctly interpreted or might be wrong. A short thing about the biology of this species. Humpback whales are divided into different populations. There's a southern population, there's a northern population, and there's a probably resident population in the Indian Ocean. But they do migrate, they do move. And they do move at very specific moments in time. By analyzing dates, we might see the patterns of movement because they should show up in dates. For instance, if we plot the number of records by month, we see that during the boreal summer, July is when we see more whales. And that should be probably correct because the whales migrate in summer and they are more easily seen when they are migrating. There are almost very little sighting of whales in December. But there's something strange here. What is strange here? Can you spot it? You see, there is a continuous increase of sightings towards August, continuous decrease of sightings towards December. But remember, time is cyclic. So what should we have here? January. Why is this plot here small and the January one is large? Why is it so? Okay, whales might migrate back. But do they actually celebrate New Year's Eve all together and then on the January 1st they migrate up? Probably not. Another dimension of time is the continuous dimension, the non-cyclic dimension. So we might have records which are old, and records which are new. I plot here only the 20th century records, and there's a little bit of the 21st records. So most sightings have been observed in the 90s, and very little sightings have been observed during the previous years, except for these 78 sightings. Why don't we have sightings here? Why don't we have any sighting from those years? Well, those might be easier to explain. People were quite busy at these times in the cities trying to avoid German subs or American subs if they were Japanese. So they don't have any time for any sightings. And then, 78, what happened in 78 with whales? Do you remember? Whales, this time, were banned for hunting. You start to see more whales because they are not hunted anymore. Does it mean that we didn't see any whales there before? Or is it just that we didn't have data? Or we had this data to buy whale hunting? Something that is worth exploring. But back to our problem with January. I plot here the dates in a different way. This is the day of the month. To a whale, a month is meaningful. A whale must know, say, which month this is in order to migrate or not. But a whale won't care about the day of the month. To a whale, the 2nd of February is basically the same thing as the 3rd of February. It doesn't make any difference. So why the whales are so easy to see on January 1st? They are so drunk after New Year's Eve that they surface all of them. Yeah. What's wrong here? On the first month, on the first day of each month, or not. Let's plot it in 2 dimensions. Let's plot it by day of month and by month. What do we see here? What do we see here? 597 sightings on the first day of January. Whereas most sightings should have occurred over the summer. Now you have the answer.
Yeah.
The answer is
Just means more people going out to
no.
There.
No. That's true for one specific date with birds. Birds do have a peak around December 24, 25.
Except
That's
for
what
those
birds.
data are not shared.
Yeah. But I've seen it. I've seen this peak. No, what's wrong here? A date record might have been digitized on an old ledger where you know that a whale has been seen in a particular year. But you don't know which day or which month. What should you do? Or what should a good database system do? Nullify month, day. But what do some database systems do? They won't accept that. They won't accept a date like 00/1920 because that date doesn't exist. So they automatically are referred to the first day of the month or the first day of January, January 1st. So you have dates which are fake. This is something that you need to look for. Dates that don't make sense, it's easy, but dates that are suspicious, such as this one, right? So one thing that we need to check in our dates. Dates that might be not exactly wrong, but just technically convenient, although these dates then would probably destroy any kind of calculation you wanted to do or the migration patterns in this case, right? What else? Let's go to this plot that we saw before. Year of record, that's fine. And how many instances are there of January 1st according to year? This is the number of instances of records happening on January 1st. It says that we are doing things right, almost right over here. But the old records from the 60s backwards have an enormous amount of wrong dates, which means that those old records probably didn't keep track of the exact date, just the year. So if we wanted to study the migration patterns of whales, this means that we might probably be restricted to studying only recent data and don't wait for that data. because we can't trust those dates. So by looking at the dates, you discover that data might not be useful, or only part of the data can be useful, which is what we expect, in fact. However, in the previous session, Tom very brilliantly has shown you how to correct dates if you are smart enough and you simply play with data. And I absolutely concur with Tom that one of the biggest joys in my life, apart from my wife and my kids, is playing with data. Well, I have several other devices too, but playing with data is really a wise. Anyway, it's enjoyable. And playing with data, with dates, means basically looking at the dates from different perspectives that offer you new insights, as we saw with the January 1st thing. Okay, remember that the date has two components, a cyclic component and a continuous one-directional component, right? So how should we plot the cyclic component? The easiest way is to do a cycle. So rather than the plot that we saw before, like this one, anytime you represent a cyclic component, a much better representation system, and I know I'm repeating myself because this is something we should talk about on Thursday, but anyway, I'll tell you this now, is this kind of temporal diagrams in which time is cyclic. This is the first day of the year, the second day of the year, this is the summer, basically summer solstice, and we go back. So you don't, or you see more easily what patterns are wrong. In this case, the maximum of the migration happens around here, which is late summer, as you saw, and you see this spike here, which is the first day of the year, which is what we were looking for. We were looking for strange patterns. We see both migrations. The migration here, the winter migration, and the summer migration where everybody's is out looking for whales, and only the courageous are looking for whales in winter in the Atlantic, because the seas tend to be very rough and people get seasick quite quickly, and they don't record whether there are whales or not. Okay, sometimes we must take into account that time has components that are natural, such as a cycle, or a longitudinal component, and sometimes are completely artificial. For instance, to a whale, a Saturday is exactly the same thing as a Tuesday, right? So we shouldn't see any pattern. The next example I'm going to show you is not from whales, but from records of animals and plants in Spain. Okay? Records of animals and plants in Spain. And I've ordered the data in a different way. This is the month, and this is the day of week. And the shades represent the amount of data that are available. Well, as expected, or not, in summer is where most people is out looking for birds or for plants. Because in winter it's murky, it's rainy, it's icy and snowing, whatever. So you don't want to go out in the field. So you have a lot of data from summers and not so much data from winter. That's okay. But look at this. We have an enormous bunch of data which have been collected on Tuesday, Wednesday, and Thursdays. Right? And in this case, most data have been collected over weekends. Why is it so? Academic publishers, scientists, who are too busy over the week with lectures or research to be able to go out to the field, so they forfeit family life and they go out to the field on weekends, and whereas the administration, officers, etc., that's part of their job, or they won't work at all on weekends, and they will probably, in Spain at least, only work on Tuesday, Wednesday, and Thursday. Friday is almost weekend, and Monday is just after Sunday, and so they don't collect much data. But this has nothing to do with biology, all right? But it does have to do with the data that you have available. Okay, now what's in a date? A date can be represented in so many different ways, so as to sometimes make things difficult. We're back to the whale dataset, all right? And it's within these 24,000 records, we find this many ways to represent a date, and all of them are different. They are not homogeneous. We tend to think that a date is something similar, something simple. February the 3rd, 2014. Not so. If you're American, you would say that. We in Europe, and probably you in Africa too, we say 3rd February. So we reserve that day and month and the year. But that's not even more convenient. If you wanted to order a data set by date, either the data set or the database recognizes the date as a date, or if it recognizes as a string, it will not be ordered correctly unless you put first the year, and then the month, and then the day, which is a natural string ordination. You put the string like that, year, month, day, and they will naturally come ordered by time. That format is called the ISO format, and that's the preferred format for a date, always. Year, month, day. So we have all these systems. This is the year, this is day, month, year, day, month, year. We don't know, yeah? Year, month, day, and day, month, year, day, month, year. So there's, why do I say that this is a day, month, year? Because this is 2, 3, and 4. 3 spaces. It's not numerical, it's probably literal, like here, whereas in some other systems, it has to be a numerical, and you have different ways to separate the components of a date, etc. Okay, so a date might have a year or not. Sometimes you don't have the year, sometimes you don't have the month, you don't have the day, you don't have neither or day or month. So you might have all these kind of combinations only in the whale alone, in the whale data set alone. And there is a preferred method, apparently, which is 6.11.904, which we might guess is day, month, year, or not. Because, remember, most sightings about whales were happening in summer. So this is probably a month, day, year. Well, you have to look at the verbatim data and try to make sense of the data somehow. And making sense of the data entails trying to know which date system they've been using. In Spain, as I said before, we use in isoform, it should be year, month, day. In an American system, they will reverse day and month. So you should try to see whether in your system there is something wrong, such as a month which is bigger than 12. If one of those components gets bigger than 12, you should know that that component is the day always. If both components are over 12, you are in trouble. Okay, this is the system, year, month, day, and you analyze it, you discover that this can't be, and then a date like this should be tagged as belonging to a different system. The problem is that sometimes you won't be able to distinguish that. If you get a number which is about 12, that's fine. But any date that is below the 12th day of the year, of the month, is something you can't never know unless you've been explicitly told that it's an American or whatever. You'll never know whether this is correct or not. So, for humbug's again, how many records did have issues? Of those records existing, only 0.2% had issues, which were strange names. But 10% of the records had geographical issues, which is a lot. Date issues are somewhere in between. Almost 2% of the existing date records, or the existing dates in the records, had issues, such as not being able to be correctly resolved. In this diagram, I tried to analyze what kind of problems might you have? Things missing or things wrong. And they tend to become a large chunk. This is another way to look at the data, another creative way, although I will go in more detail on Thursday over it. This diagram that we created several years ago represents the cyclic component in polar coordinates and the and the unidirectional component as a radius. So what we see here is January 1st, you see this spoke here, all those records having January 1st, and then you go over here, February, March, etc., August, July, August, etc., and back. But those are the oldest records and the newest records. As expected, most records occur over the past 30 years. The color here represents the amount of records that are available. Different data sets might have different patterns. In this pattern, you see, those spokes here, we do know what do they mean now. What do they mean? Records that had months but didn't have a day. So they were assigned to the first day of the month. You see this? You see you are in trouble. That data set has a problem. Another curious thing you can see here in this chronogram. You see this void here, this black belt? What is it? Submarines. Lack of data, all right? Over the Second World War. This band here is Second World War. You might also separate the data by components. In this plot, each ring belongs to one provider, one different data set. Different data sets, different patterns. When you combine them, some of the common features might match up, and some others might not. So sometimes it pays to separate the data by components, as Town did with the Cameroon data. So in summary, what's the main issue with check-in time? We haven't still gotten to the main issue, and we are going now to the main issue with check-in time. We do have a very important issue with time, an extremely important issue with time. Anybody can guess which issue is this? You're suffering from this issue, all of you. I'm suffering more, and Town probably even more. Time is unidimensional. So whenever you don't have a record in time, you will never have it. You cannot fill gaps of all records, because if they don't exist, there is no possibility that I can go and get sightings of whales in 1940 if no sightings were available. You can go back to a place that you haven't sampled and get samples. So you can, to some extent, you can fill voids in geographical sampling. You cannot, never, ever fill a void in time space. That's not possible. From now on, you might fill. I mean, you detect that you have a lack of data from winter. Okay, you sample more on winter, but you don't have a baseline of how things were 50 years ago. There's no way you can know that. So there's no time machine for dates, unfortunately. So workflow with dealing with dates. First, try to separate the components because they will need to be treated separately. Months, days, years. Check outstanding date frequencies. This is often done by pivoting over providers or over date components. Most examples you saw before were done with a simple pivot table on Excel. Check impossible dates, months beyond the 12th month. Look, some people represent the first month of the year as 0, which is another problem. Years in the future, by definition, we can't have existing biodiversity data which has not been already collected. But as you saw in Town's example, that there were extraterrestrial coordinates, we do have future dates in the datasets. Often they represent unknown dates. Check potential voids. Look, for instance, at the first day or first month frequencies. Look at day-to-day frequencies if you can. and try to get everything homogenized again in an additional field, never in the originals, in an additional field, in ISO format, year, month, day. If you don't know an exact date, don't make it up, ever. Leave it blank. All right? Yes?
More just a comment, but we all fall into the temptation, or at least feel the temptation, to use the date formats in the programs we use.
Ooh.
And that is a recipe for absolute disaster.
I can vouch for it, because I did that mistake once, about 8 years ago, I think. When I invented the chronogram, this polar plot, the first results I got me absolutely surprised, because I saw 12 spokes, 12 wide spokes. And I say, got it. Month, day reversed, which means that the first half of the month always gets twice as many records. And I show it to a few colleagues, and I even show it in a poster. And later it was discovered that yes, this problem exists, but not to the extent I've seen it. What happened was that the data system I was using, which was now Microsoft at that time, Xbase, Foxbase to be precise, had a bug, an undocumented bug when converting dates. And it automatically converted the dates to American format if the dates had been imported with a comma rather than a dot as a CSV. So it was an issue with the database that went completely unnoticed. I made the mistake of believing that I was looking at the data correctly plotted, whereas I was looking at 1/3 of my data coming from a different source, which had been wrongly interpreted by the database system. This might happen, or perhaps no longer, but it has happened in the past. It might happen in the future. You're right. You're absolutely right.
I think I would say it still exists if you're using Excel.
Excel has a peculiar problem that it cannot deal with dates older than 1901 unless you plug in a special plugin that allows you to deal with older dates. But if you convert everything to a numerical value like ISO, you don't need to use the date functions at all. You basically play with numbers, and that's always safer. Always safer. Almost always safer.